All right, for our next speaker is Dr. Richard Drucker. He's the ANMA president. He's a highly respected doctor in the field of natural health. He was named the ANMA president in 2020. He's the founder and CEO of Drucker Labs. He's dedicated his life to the pursuit of exceptional, organically bound, and proprietary nutritional products. Dr. Drucker's topic for today is Beyond Survival, the evolution of healing carbon.
Good enough.
All right.
Close enough.
All right.
Okay. Good. Thanks, guys. Don't need that too, right? Too much? Probably. Better. Okay. Well, good afternoon to everybody. Everybody's like wide awake, bushy. Like, okay. Do you guys have, first question, did you have a good banquet? Who went to the banquet? Okay, so good. Was the food good? Okay, I don't want to hear about that. Until after. I'm kidding. Just glad to be here. We have a lot to cover. So I probably got 2 or 3 hours worth of good stuff to cover in an hour. Oh, Marty says in like an hour and 59 minutes. So just kidding, it's an hour, I get an hour, that's it. So we want to talk today about some good stuff. We want to talk about carbon, and we want to talk about the understanding of carbon. We want to create an understanding of carbon. And we want to do this because we, as living beings, are made up of carbon. So I pretty much dedicated, you turn that, is that better? Is that better? Okay. I've dedicated my life, it's a short life, you know, like 60 years or something like that, to, not all of that, but at least half of it, more, probably like closer to 30 years, to understanding carbon and to integrating carbon into my life. And that's the basis. I want people to, when they leave today, to at least have a very decent understanding of carbon. Carbon is a very, very important molecule. It's one of the most important molecules on the planet. It's what we are made up of. So I'm going to spend the next, whatever, if Marty gives me 3 hours, great. If I get 2 hours, really good, but I think it's just going to be an hour. So I'm going to try my best to explain to you guys why carbon is such an important element in not just chemistry, but in our foods and in the things that we are ingesting. And then, ultimately, why we would want carbon in our life every day from a dietary supplement perspective. How many people in the room are taking dietary supplements? Just curious. Okay, one more time. I just want to look around. How many people? So, let me put it another way. Is there anybody in the room that doesn't take a dietary supplement? Anybody? Oh, okay, we got a person. So good, this is good. And I'd like to talk to you afterwards because most people are here for CEUs to get understanding and then to learn about like new supplements and things in the market and new science, new discoveries. So we have some good stuff today. Today we're going to talk about the basics of carbon. It's something we could spend 3 or 4 or 5 hours talking about. But I want you to understand it because we as humans, plants as extensions of humans, are living. So anything that's living, anything that's breathing, anything that's taking in oxygen or carbon dioxide, for that matter, is something that is what? Alive. And if it's alive, then it contains carbon. So carbon comes in many different forms. For example, the table, the chairs, the computer screen contains an inorganic form of carbon called carbonate. Anybody heard of carbonate before? So we understand carbon is living, breathing, and respirating, and carbonate is inert. Basic understanding? So let's look at the definition. Carbon is a fundamental chemical element with symbol C in the atomic number 6. It is a nonmetal known for its ability to form 4 stable covalent bonds, allowing it to create a wide variety of compounds. So we just kind of talked about that. Carbon is found in various forms, including graphite, diamonds, and carbon fiber, like, for example, carbonate. each with distinct properties and uses. Carbon is a key building block of all organic molecules, making it essential for life and biological processes. So this history and the study of carbon is what I've dedicated my life to. Uh-oh. What did I do? Yeah, that's okay. I'll just keep doing that. So, I don't know why my computer is jumping around. It's kind of sensitive. So, we want to understand the background and the history of carbon. The study of carbon dates back to ancient times when it was identified in forms such as soot and charcoal. However, it wasn't until the 18th century that carbon was recognized as a distinct element. People think it's something we recognized in the 15th, 16th, and 17th century, but that's not the case. It's been here, but we haven't actually recognized it molecularly. So over time, scientists discovered carbon's ability to form multiple allotropes, each with unique properties and applications. The discovery of fullerene structures and carbon nanotubes in the late 20th century marked significant milestones, leading to advancements in material science and nanotechnology. So this is an important understanding. It is something that is fairly new, been around for a long time, but everybody's heard of carbon dating, right? There's some form of carbon dating. Everybody understands carbon dating. It's because we're using carbon as a means or a mechanism to try to understand how old something might be. And we use carbon dating as a process to do that. It's a long process that's on a lecture of itself. But I want you to understand that carbon, living, carbonate, inert. So the study of life is the study of what? Carbon. We are made up of carbon. Plants are made up of carbon. Your best friend is made up of carbon. Your dog is made up of carbon. Your car is made up of what? Carbonate. It's inert, it's metallic, it's got carbon particles in it, but again, it's not living, breathing, or respirating. We are made up of methyls, aromatic protonates, heterocyclics, carbonyls, carboxyls, quinones, ketone, ketene-like carbonyls. These are very specific carbon molecules. I have studied carbon for so long that it's a part of me, but I'm made of carbon. So I felt like, oh my God, I love loving carbon. So it's great because things I didn't understand about it over time have become clearer, and possibly even more questions get raised, right? Because you start to study something and then you think you understand it a little bit more as you go into it, but you only realize that it's even more confusing than ever. But carbon's diverse bonding capabilities have paved the way for numerous scientific breakthroughs and practical applications in science today. So again, carbon is a chemical element. It has a simple C. Everybody in the room has taken some kind of science at some point in your life, right? Med school or wherever. And you have a basic understanding of carbon. You've heard of it. It's a very critical element. It's one of the most critical elements on the periodic table. It is a non-metallic and tetravalent, meaning that its atoms are able to form up to 4 covalent bonds due to its valence shell exhibiting 4 electrons. It belongs to group 14 of the periodic table. Not that any of this really is going to stick with you. It's okay. But just understand some basic information. Carbon makes up about, 0.025-ish percent of the Earth's crust. So the atomic number of carbon is 6, which represents the number of electrons. It's represented by the symbol C and is non-metal. It has 6 protons, 6 neutrons, 6 electrons. Okay, you're not in a science class, but it is important to understand it because it is the single most important element on the periodic table. Carbon atom is considered to be special and unique because it can bond with other carbon atoms to be an almost unlimited degree. It can bond. It is because its atom is very small in size and can conveniently fit in as part of larger molecules. Each of its atoms has 4 electrons in its outer shell called valence electrons and can form chemical bonds, covalent bonds, with other atoms and molecules. It's like, why is this guy spending so much time on carbon? Why? Because at some point I'm going to link in how and why we utilize carbon today in a very unique way to create nutrition. So understanding carbon is important. Understanding that we're made up of it is important. So if we could just figure out a way to match or marry carbon in terms of a nutritional infrastructure into our cells or coming assimilation into our bodies, then in a sense it's like a perfect tissue match or a perfect cellular match, because you don't have to mask anything, you don't have to create anything. You're already carbon. We're already breathing. This is not. This is carbonate. It's inert. So wouldn't it be cool if we could come up with a way or a method, a methodology to introduce carbon in a nutritional, cellular, bioavailable, utilizable form that is immediately accessible at the intercellular level so your body can utilize. I don't know that you can say anything is 100% utilized, but it can be utilized at a very rapid, very high degree, very rapid amount into the cell. The mitochondria and the cytoplasm of the cell are made up of carbon. So if carbon passes through the epithelium and it comes into the cell, the mitochondria and the cytoplasm of the cell say, oh my gosh, I understand that. I'm made up of the same thing it's made up of. The thing is, it's just never been done. So I've spent the last minutes, 30 years, trying to come up with exactly how we might do something like that. So we need to understand why we're talking about carbon today so that we can understand why the nutritional infrastructure coming into the body or being absorbed cellularly is so important if it contains carbon. Because the body already